All right, just a couple additional notes here. These aren't your notes, but I want to talk you through them real quickly. And these are going to be the ideas of even and odd functions. And so, how do we know if a function is even or odd? Well, if a function of f of negative x is equal to f of x, then that function is said to be even. And let's go ahead and take a look at that. If we have y equals x to the fourth minus x squared, and we are going to plug in for x, we're going to plug in negative x. And if we end up back at y equals x to the fourth minus x squared, and then it is even. So as we substitute those values in, we have y equals negative x to the fourth minus negative x squared, and hopefully you're seeing that, hey, this is going to end up being even. So negative x times negative x times negative x times negative x, that's positive x to the fourth, and minus, well, what's negative x squared? That's positive x squared. And so we end up, and remember, we're subtracting that value. And so we end up back at our original function. So this is even. This function is said to be even. For a function to be odd, then f of negative x will give us the output of negative f of x. This will give us an odd function. And let's take a look at that one here. If we have, for example, y equals x cubed minus x, and we substitute in those negative x values, then we're going to end up with y equals negative x cubed minus negative x, which will, get a little short on room, which will give us y equals negative x times negative x times negative x is negative x cubed, and then minus negative x is plus x. Now, if we were to, again, we said if it was a negative f of x, essentially if it was negative y, then we'd be there, and hopefully you can see, hey, if we divided both sides by negative 1 or factored out a negative 1, we would have negative, so we're going to divide everything by negative 1, negative y equals x cubed, positive x cubed, minus x. And there's our negative y. And maybe to make it even more explicit, y equals, if we divide both sides again by negative 1, and so really just had factored out that negative 1 out in front, we'd have negative our original function, x cubed minus x. So notice negative f of x. Hope that makes a little sense. Oh, one other point I want to bring up for our quadratics. We already this is in terms of talking about symmetry. We already know where our axis of symmetry is at. We have an axis of symmetry at negative b over 2a. That is an x equals, that's the line there, x equals negative b over 2a. With a cubic, we do have a similar thing going on. A cubic doesn't have a axis of symmetry. It's going to have a point of symmetry. Point of symmetry. And it's going to be at, so again, point of symmetry, not axis. And it's going to be at x equals negative b over 3a. All right, let's quickly take a look at that one as well. So what I did is I went ahead and graphed y equals x times x squared minus 1. So just wanted to get your roots in here and give you the one that you could take a look at. And we end up with our point of symmetry is at 0, 0. Now if we were to move it around, and notice that that's the point of symmetry. Everything gets reflected right through that point. It's not a line of symmetry because we don't have the rest of our graph came up here. It's not a parabola, so again, just a point of symmetry. But if we were to start dragging this around, multiply this out, and you'll get your negative 3, or sorry, negative b over 3a would give you 2 this time. And over here we'd have, it's still going to be 2, because again, our point of symmetry, just the x value of it, will be right here. And so go ahead and play around with that a little bit. Show yourself that it is in fact true. But yeah, hope this helps.